Hi there, in today's video we are going to talk about how to assemble and solder the project design for the IoT Home Automation and Surveillance system. For this, we would be using two pieces of single-channel solid-state relay module. As shown here on this table, however, to control the DC fan we would use a TIP 41C NPN transistor. We are disassembling the DC fan. The plan is to control the DC motor of the fan only using a common emitter-follower configuration of the transistor circuitry.
Once the DC hand fan has been disassembled, we can proceed to measure the voltage of the DC fan. The idea is to find out what is the maximum voltage that is powering the DC fan at its maximum speed. Once we are able to find out this voltage, we can be able to reverse engineer it using the control widget from Blink Dashboard and also using the TIP.41C NPN transistor configuration. Using the multimeter instrument and its reading set to the DC voltage measurement reading, we can see that the voltage of the DC fan, when we crank up the speed, by pressing the speed button 3 times. The measured voltage is displayed as 7.89 volts. We can set the supply voltage from the collector to range from 0 volts to 9 volts.
Once we have gotten this voltage level, we can proceed to remove all the electronics parts in the mini DC fan. Using a lead sucker, we desoldered all the wires that were useful to us. Now, with the DC mini stripped bare, we can also decide to either cut more openings for the ventilation of the DC fan or just leave it as it is. This feat can be achieved using a cutting machine, just the one used in this video. Or you can just leave it. Next, we move to the soldering part of the project design. To get this project soldered permanently, we would need a Vero board for that. Since most of our parts for the project design already came in modules, we can just use a small Vero board as shown here. Any good soldering iron would do, however for us, we used a USB soldering iron. The USB soldering iron works for us because we can just plug it into our PC USB port and use it to solder whatever we want to solder. However, the soldering iron itself came with its own solder. This is more flexible and softer to touch and it easily melts under the heat of the soldering iron. The USB soldering iron has its own temperature regulation and we used the highest temperature for this job. The USB soldering iron kits comes with the various tips to be used with it. You can bring this out, insert and fasten the tip firmly in, and plug the USB flex at the bottom. And once plugged into a 5-volt USB port, the soldering iron would turn green. Depending on the temperature that we want. We place the component we want to solder and we can proceed to soldering it. Once we are done soldering, we can proceed to making and coupling the model. We will tackle this part on the next video. It is not that much difficult and you can choose to make any model of your choice. For us, we chose to model something that has the resemblance of a living room, and we mounted all the devices involved in the best position to help us carry out the functionalities of the smart home automation design.